Hello, everyone. This is Bhavana Rakesh and Yenjue from STI modeling from the OSTI office of the Weather Service. This is our UFS webinar series. Today's presentation is from Dr. Juliana Diaz. I just wanted to give you a quick walkthrough of the UFS portal where all these webinar series are made available to the users. The UFS portal is available at ufscommunity.org. And through this portal, you can sign up for upcoming announcements of the UFS webinar. If you scroll down in the home page to the Stay Connected section, you can click on the subscribe to announcement icon, and then it takes you to this form where you can sign up for the quarterly report, the webinar announcement, and other announcements through this page. You also have access to view all the past webinars through the webinar archive page, and all the past webinars, the YouTube recording of the webinars and the presentations used for those talks are available on this page as well. Upcoming webinars are featured in this page where we have a table of past and upcoming webinars that have been scheduled for now. So with this little bit of housekeeping announcement, I'll hand you over to Dr. Jessie Carmen to introduce you to the speaker.
Okay, thank you very much. Dr. Juliana Diaz was at Ceres when this work started, but she has since transferred to NOAA's Physical Sciences Lab. She has a long history of publications in tropical interactions, both from field campaigns and modeling studies. The present funded work looks at both MJO and QBO interactions and their impacts on U.S. precipitation skill at the S2S time period. But today's talk is going to narrow a little bit and discuss the influence of UFS tropical forecast errors on the extratropical latitudes. So I'm looking forward to it. Please take it away, Dr. Juliana Diaz.
Thank you.
Sorry, a few more words about logistics. We are going to leave 15 minutes at the end of the talk. Please type in your questions in the question box. I'm going to unmute you once the talk is finished. Thank you.
All right, can you guys see my first slide?
Yes.
Okay, very good. Thank you, Jessie, for the introduction. Thank you for the invitation to give this seminar. Here you can see a pre-pandemic picture of my collaborators in this work, Stefan Tulik, Maria Gana, and George Kilates at the Physical Science Lab in Boulder. And as you might be guessing, the motivation for this work comes from what we know about tropical to extratropical teleconnections, in particular at subseasonal timescales, and I'll start with that. This is what we find is here illustrated in this schematic from this nice paper by Christiane Stan from a couple of years ago, where she's illustrating various pathways of communication between tropics and extratropics. And for the purpose of this talk, what's important here is that the atmospheric response to variations in tropical latent heating is well known to extend beyond its source region. And this type of linkages are reasonably well understood through what's known as Rossby waves theory, and in which the upper level divergence fields in the tropics are the main driver of this communication to higher latitudes. And to be a little bit less abstract about this type of relationship, I'm going to show you a couple of figures from this paper by Brent Statter at NCAR, which is particularly revealing in my view. And in this work, he used Chem3 and he superimposed a 2-day pulse of heat to the tropics, and this is illustrated here by this yellow dot. And he superimposed this to many realizations of January 1st in a free run of Chem 3. And what you're looking at is the response 3 days later after this pulse of heat is switched off. So the pulse of heat is mimicking what a large thunderstorm or MJO-like type of disturbance in the tropics would do to the tropical atmosphere. And you can see that by day 3, you have this upper level response extending well beyond the source region. He also moved this heat source along longitudes. And here you can see in terms of root mean square that you indeed get this circulation response primarily in the northern hemisphere for the winter season by day 3. And you can then look at this as a function of integration time and other variables. For example, here's on the right figure, you're looking at sea level pressure, and you can see this peak response in the mid latitudes at around day 7. Of course, if you're thinking of predictions, this is a bit more complicated because the extratropical response will depend not only on the location and character of tropical heating, but also will be modulated by the basic state, which is itself modulated by ENSO, MJO, and etc. And there's a rich body of research that has looked at these dependencies. But for the purpose of what I'm going to show you today, what matters is that there is a dynamical pathway for tropical forecast errors to move away from low latitudes towards high latitudes. And this is seems to be a primary mechanism over the northern hemisphere during the winter season. So one way to test this idea that tropical forecast errors impact subseasonal mid-latitude predictions is to perform what's known as relaxation types of experiments. ECMWF has a long history of this type of experiments. I'm listing here some of the main papers on the topic. And a relaxation experiment is essentially a nudging experiment type of approach where you relax all of your prognostic variables to analysis or reanalysis over a limited portion of your domain, here the tropics. So your forecasts are running free away from the nudging region. And in general, this type of approach shows that there is an influence between this artificial reduction of tropical errors and an improvement in predictions in the mid-latitudes. And I'm going to show you some figures from Young et al. 2010 illustrating that. So here on the top, you're looking at roughly week 1, 2, and 3 mean absolute errors in 500 geopotential heights for a 10-year set of reforecasts. And then on the next row, you're looking at the difference between mean absolute errors of a set of forecasts where SSTs are relaxed to observations versus the control. And then finally, at the bottom, you're looking at the case where the entire tropical atmosphere was relaxed to reanalysis. So blue shading is indicating the regions where we see a reduction in mean absolute errors, and you can see that by week 2, 3, you have this substantial reduction in errors in large areas of the Northern Hemisphere, in particular Northeast Pacific and United States. So this seems to demonstrate this type of relationship. It does also bring a number of questions that we're interested in. For example, would we see a similar imprint in terms of error reduction on surface variables, such as precipitation temperature? This relaxation extends to the subtropics. So what is the role of convection near the equator versus the circulation errors associated with the circulation response in the subtropics, and so on. And I think the common theme on this type of questions is the more broad question of how much of this is achievable via model improvement versus how much is not, just because of intrinsic predictability barriers, perhaps in the tropics. So to at least partially address some of these questions, we implemented this type of experiment in an early version of the UFS. So it's an uncoupled, those are uncoupled forecasts. Our experiments are all run on Gaia. Thank you to Dave DeWitt for arranging time, HPC time for us. They are relatively coarse resolution, about 1 degree, because as you might imagine, these reforecasts are expensive. So far, we are covering November 1st to March 31st with initializations every 5 days, and our forecasts go out to 30 days. We are relaxing of our tropical forecasts to air interim reanalysis. And then if you see me saying that I'm relaxing all variables, what I mean is that zonal winds, meridional winds, temperature, specific humidity and pressure are relaxed to air interim. And what I'm going to show next is some results we have from a few experiments. They are listed here. So when I say control forecast, I'm referring to a free UFS forecast. The Y tropical nudging means that I nudged all variables within this region marked by the dash profile here, and this is exactly what Young et al. Used in his work, and that's a way to compare, to check whether our results are consistent with what we've seen in previous studies. We have also looked at a case where we relax only winds to reanalysis, and the reason for that will show up in one of my slides in a little bit. And then we are also looking at a case where we nudge only, we have only full nudging between 5 south and 5 north, and our forecasts are free beyond 20 degrees, to address a little bit this issue of the role of latent heating near the equator versus the larger scale response circulation that covers the subtropics. So again, our experiment period covers November through March. What you're going to be looking at are averages between 1999 and 2018. So we have about 620 reforecasts in each of these sets. One thing to keep in mind is that when you think about this Rossby wave type of argument that connects variability in the tropics to the extratropics, there are two main pieces of it. One is the anomalies, and the other is the basic state. So it's one, you might be influencing predictions, remote predictions, because you're changing the basic state or variability, and therefore it's interesting to see what nudging does to, for example, zonal mean fields. And that's what I'm showing here with upper level winds. You can see that at week 1, all of our reforecasts match pretty well with air interim, but there are some difference by week 4. For example, you can see some changes in the subtropical jets, where the free UFS forecasts tend to underestimate a little bit the intensity of the jets, and the nudge cases where we nudge all variables tend to overestimate. And these changes are consistent with what with the upper level temperature changes that we are imposing In particular, the UFS is known to have this cold bias from pole to pole in upper level temperatures that is here at week 1 and it's amplified by week 4. And what you're looking at is the distance between the black curve for reanalysis and the gray curve for reforecast. And you can see that by nudging the tropics, we increase the temperature at upper levels over this nudge region, as shown here by the red and blue lines, but we don't elsewhere. So we are essentially increasing, enhancing the meridional temperature gradient in the subtropics, which then manifests in the jet position and intensity. There are also changes to precipitation that are primarily in the region where we are nudging. For example, we know that the UFS tends to underestimate precipitation in the tropics, but when we nudge, we tend to overestimate slightly this temperature unless we don't nudge all fields, which is shown in green here. And as I mentioned, when we nudge only winds, we don't affect this temperature bias in the model, and that's one reason why we thought it was interesting to carry over this experiment, because that allows us to test any potential impact of this temperature bias on our low to high latitude error relationships. Okay, so I'm going to show you 2 types of analysis we have done so far with this type of experiments. One is based on mean absolute errors, and that help us see if our results match up with our expectations from previous studies. And then on the second part, I'm going to talk a little bit about anomaly pattern correlations over the Western US and how reducing errors in the tropics affects those subseasonal predictions in terms of anomalies. So this is a figure similar to what I showed you at the beginning. On the top row, you're looking at Z500 week 1, from left to right, week 1 to 4 mean absolute errors in the free forecast. And then the second row is the difference between mean absolute errors in the case where we had that wide tropic, so similar to Young et al., and the free forecast. And I normalized this difference by the absolute value. So what you're looking at is on the color scale here on the right are percentages of the absolute error in the control simulation. And again, where you see blues, you're seeing regions where errors are reduced. And where you see dots, it simply means that the difference are not statistically significant. And you can see that by week 2 and increasing towards week 4, there's this large regions in the North Pacific and Atlantic, and to some extent the Western US, where errors are reduced. And this is consistent with what other people have seen in different models. And you can also see that this error reduction is stronger in the Northern Hemisphere than it is in the Southern Hemisphere during this November through March period. And what's interesting here is that you can also see this error reduction in precipitation predictions, and that's what the bottom row here is showing. Again, it's a percent normalized difference. So you can see this regions where you are outside your nudging area and you're seeing reductions of about 30 to 40% in mean absolute errors at week 3 and 4, 2, 3, and 4. And we can take a zoom on over the United States, which is also interesting, and it's shown here for this wide tropics experiment. You can see there is definitely an edge effect where the closer you are to your nudge region, the stronger the error reduction is, but at week 2, 3, and 4, you can see this region extending all the way over the western US coast, where you see significant improvements in mean absolute errors when you nudge the tropics. And the patterns look pretty similar when we do the narrow tropical nudging case, but of course the amplitude of this reduction is less, but still significant. I'm not showing here, but when you nudge only the wings, you see something very similar to week 3 and 4 here at the bottom. So at this point, I'm just going to quickly summarize what we saw here. As expected from previous studies, it seems like mid-latitude mean absolute errors tend to be reduced when we nudge the tropics. This error reduction is stronger over the North Pacific and Western United States, where we saw reductions of 20 to 40% in precipitation mean absolute errors. And even when we do that very narrow case of nudging, we still see some significant error reductions over those areas. And then finally, I didn't emphasize that too much here, but the impact we see is similar when we nudge all variables versus winds only, which reinforces this idea that there is it's really a dynamical linkage between tropics and tropical forecast errors. And this is all summarized in this figure here on the right, where we're looking at mean absolute errors in geopotential heights as a function of lead day. The gray line is showing the control mean absolute error. The shaded area is my confidence interval based on some bootstrap resampling of our 620 reforecasts, and then you can see that for all nudging experiments, you see an error reduction. For the wide setup, it seems like when we nudge all variables versus only winds yields about the same type of error growth. And then again, it's interesting that we see that in precipitation, even in a global sense. Here I'm averaging mean absolute error over the entire globe in this 35 to 55 degrees band. Now, one thing that I didn't fully appreciate before starting this project is that when we look at a map and we see areas of error reduction, this is of course an average. So there are reforecasts that are improved when you nudge the tropics, but there are also cases where you make the forecasts worse. And that's what my scatter plot here on the right is showing. On the x-axis, you're looking at the mean absolute error average over this red box for the control run. The y-axis is showing each of the mean absolute error for each reforecast for the nudge experiment. And here is the blue is for the wide tropics, green for winds only in wide tropics, and then red for the narrow tropics. And the way to interpret this is that if your symbol is falling along the diagonal line, it would mean that the nudging, tropical nudging had no impact on your errors in this region. If you are below the diagonal line, you improved skill. And you can see that there are more symbols below the line, but there are certainly cases where the forecast is worse when you nudge the tropics. And I think that this is actually a good thing to look at, because better understanding of when nudging is effective at reducing remote errors might lead us to better understand what is the source of this low latitude tropical errors. And that's what I'm gonna talk next. But I'm also going to focus on anomalies because for one reason, qualitatively, those errors, the spread is related to, in mean absolute error and anomaly pattern correlations are related, and it's always good to see if there's some consistency across different skill metrics. So moving on to anomaly pattern correlations, I'm going to continue to focus on this area of the Western United States as an illustration, but you could look at this anywhere that you would want to. And as I said, results tend to be pretty consistent in the sense that here these bar plots are showing anomaly pattern correlations for week 1, 2, 3, and 4. And you can see that at week 1, errors are very similar across our 4 sets of reforecasts. But by week 2 and even more 3 and 4, you can see that when you nudge the tropics in average, you improve your forecast over this red region in the western that covers the Western United States. And going back to the spread, we decided to first take a look at how the nudging impacts forecasts as a function of their original skill. So we can look at histograms of 3 forecast skills, and that's what I'm showing here, week 2, 3, and 4. At week 2, you can see that most of our reforecasts perform reasonably well in terms of Z500, and by week 4, you have more of a normal uniform distribution, and that's similar for precipitation. And now we're going to look at how within each of these bins of 3 forecast skill, what does tropical nudging do as a function of increasing anomaly pattern correlations in the 3 forecasts? And I'll do that by looking at similar scatter plots as I showed before. So here on the x-axis, you're seeing the anomaly pattern correlation for the control forecast. In the y-axis, you're looking at the anomaly pattern correlations for the nudge experiments. Again, those light colored symbols represent each of our forecasts. And what I added here is the medium anomaly pattern correlation in each of those bins that you see in the histogram. And again, the way to interpret this is that if your median is sitting at the diagonal, it would mean that the nudging had no impact on the forecast over that red box. But if you are sitting above, as you are for Z500 at week 2, it means that in average, you're making your forecasts better when you nudge the tropics. And what you can see from here is that the tropical nudging is particularly effective at raising the mean skill for forecasts that had low skill to begin with. And that's true if you look at precipitation as well, where the for forecasts that you already had some skill, you don't seem to be as impactful as the ones where you had low skill to begin with. And that's also true at week 3 and 4, where you see this large distance between the median, between the diagonal and the median anomaly pattern correlation when you nudge the tropics. So that doesn't necessarily mean that this added skill for originally not skillful forecast is coming from the tropics. And that's because there might be an edge effect from the nudging region in the same way that a regional forecast would be impacted by boundaries, prescribed boundaries, or in other words, the nudging carries information from what's at low from the tropics, what's at lower latitudes, but it also carries some information from the extratropics itself. So the question is whether this improvement is coming because we are reducing errors in the near the equator, or is just because we are providing some information from the extratropics itself. And to test that, we performed 2 other sets of reforecasts, and where we nudged the tropics for, in one case, only the first 7 days of the forecast cycle, and in the second case for 2 weeks. And that's under the assumption that by week 3 or 4, especially in our week 1 only experiment, we should be removed from this boundary effect. And here I'm illustrating how the anomaly pattern correlation over 35 north to 55 north changes when we do that. So you can see that for the first 13 days, the 3 experiments have about the same skill, even though the tropical nudging stopped at day 7. So there's this like 5 days lag that you extend skill from nudging the tropics, and then you see a similar lag on when you nudge for 2 weeks, where by day 19 you see this separation between the case where we nudged the 4 weeks versus when we stopped at week 2. And that's true in precipitation as well, but of course skill is much lower, and it's hard to see those numbers. But the lags are actually pretty similar across not just Z500 and precipitation, but for most variables that we have looked at. So now we can look at the similar scatter plots that we are looking at, and now I'm showing only this 3 experiments. And at week 2, especially given the lag, 5 days lag that you saw, you wouldn't expect any difference in this median skill for the nudge forecast as a function of the free forecast. But then by week 3, it's interesting that you still see a improvement on the low skill forecast, even when you turned off nudging at week 1, and similarly at week 4, you can see that you're still tending to increase skill of the originally low skill cases. And that's similar for precipitation as well. So that seems to indicate that the skill might be coming from the tropics, and that one way to further look into this is to look at what happens to the tropical forecasts when we stop nudging, and that's what I'm showing now. These are similar scatter plots, but now I'm looking at this 20 south to 20 north band, and you can see that even though we stopped nudging the tropics at week 1, at week 2 you're still performing better than your free forecast, and even at week 3. So perhaps what we see in the mid latitudes is an impact of this overall improved tropical variability beyond the week 1, and a similar argument can be made for the week 2 experiment. And you can also see that nudging is working, because if you look at the performance APC in the tropics, you tend to not change with lead time. In any event, it seems like what we see in terms of the extratropical forecast skill change might be coming from the tropics, and but we think that there's still a lot more to be looked at in this type of an analysis. One thing that Jesse mentioned is our work on MJO QBO connections and how those interactions might impact the extratropical skill. So that's certainly something we are interested in looking at. that can be influenced by ENSO. Unfortunately, our 1999 to 2018 period is heavily dominated by weak La Nina, so we don't cover a lot of ENSO states, which might make this type of analysis a little bit more challenging. There's the role of the MJO itself, and in general, just I think this seems to be a productive path to relate the impact of nudging to the atmospheric overall basic stage. And I'm going to illustrate this with just one analysis that we have done very recently, where we started looking at composites based on whether you improved or not your forecast, and also based on whether the original forecast had skill or not. So for example, we can look at all the cases where we improved the skill of a forecast that was already had some skill. And again, I'm looking at precipitation over the Western US, and I've done that, for example, for week 1 zonal upper level zonal winds, which shows that in general, when you improve this forecast at week 3, you have a stronger subtropical jet, as opposed to when you make those forecasts worse, and which are associated with a weakening of the jet. And then you can see that there's also a substantial difference between a forecast that was skillful to begin with and not, by looking at the same type of composites over this cases where you originally had no skill, and then we see that there doesn't seem to be any systematic change in the subtropical jets associated with those cases. And you can look at other variables, for example, OLR and sea surface temperature, or whatever variable you are interested in, and that's something we're just beginning to pursue. Okay, so to summarize, we produced this 30 days UFS reforecast. We have about 620 of them in a couple of different setups. The types of experiments we are performing, actually right now running, are similar experiments, but now covering April to October. We're interested in this for a few reasons. One would be to be able to have a further look on the role of the strength and position of the jets in this remote influence by from the tropics. The other is looking at tropical cyclones and how those influence the eastern United States. Now, we also have this set of experiments where we are planning on testing the role of the tropical troposphere versus stratosphere, again, bringing back this QBO-MJO relationship that Jesse mentioned. And finally, I think that there is an underlying assumption that a lot of what we see in terms of at least Western United States and the tropics is coming from the Indo-Pacific region, and that's something that we can test by doing some regional tropical nudging experiments. In terms of what we've seen so far, I hope I have convinced you that tropical nudging tends to have a positive impact on subseasonal Northern Hemisphere mid-latitude predictions, particularly over the Western United States. It's interesting to see that while skill is really low for precipitation in those regions, you still see a substantial improvement when you remove errors from the tropics. Of course, there's this issue that sometimes we actually degrade skill, which means that the tropics doesn't always impact the mid-latitude forecast in a positive way. But we think that that might be related to the basic stage, as theory predicts, and we have some evidence that the strength of the subtropical jets might be playing some role in these relationships. And then once again, we think that by testing and understanding those various nudging configurations, we can better characterize the sources of errors that are affecting week 2 and 4 predictions over the Northern Hemisphere, as well as what portion of this potential skill is realizable. And that's one of the downsides of nudging, that you are correcting, you're holding the forecast to observations, and you don't know what portion of that is predictable and what's not. And that's what I had for today. A lot of this that I presented here are pretty new. They are pretty new results, and we are working on a manuscript, but some earlier results can be seen in this link that I think will be shared with all of you. Thank you.
Thank you, Juliana. I'm gonna unmute folks because, oh, I saw a question.
Yeah, there are a couple of questions. We can start with Craig Long. I'm going to unmute Craig. Craig, you're unmuted.
Maybe Bhavana, you just read the question.
Okay, I want to read out Craig's question. He's asking, is nudging dependent upon ENSO state and DOY?
So not, we are always nudging variables to the analysis regardless of ENSO state. What we can do is composite our results on different ENSO states.
Okay. Next question is from Fangling. I'm going to unmute Fangling.
Okay, I was wondering the nudging is applied to the first few hours or the entire forecast length, but if from your later talk, I know.
Sorry, could you repeat your question? It was breaking out.
The question is the nudging, the replay applied to the first few hours of the forecast or to the entire length of the forecast?
So in most of what I showed, we applied continuously throughout the forecast cycle, so for 4 weeks. And then towards the end, I showed you a couple of figures from cases where we applied that replay only during the first 7 days or only first 14 days of the forecast cycle.
Actually, I haven't finished my question. I was muted again. So I noticed from your later talk, you applied mostly the nudging to the entire forecast length. So I'm still wondering, is there any way you can isolate the error from analysis and the model intrinsic error, the model forecast error, by say if you're nudging only the first few hours compared to the nudging to the entire forecast length, if say, is there any difference in the outcome?
Yeah, so that's partially addressed in this figure here, where you can see we nudge only the first 7 days of those 30 days forecasts, and you can see that in the dash line, you have about the same skill as the case where you nudge the entire period for the first 13 days. And then beyond that, you see a drop in mid-latitude skill because you're not continuously forcing the tropics. And then
still a model and physics dynamics error issue instead of the analysis initial problem.
It looks like you gain about 5 days in this 35 to 55 north region by having a perfect tropics, which is of course not realizable.
Okay, thanks.
Next question is from Jimmy Dudia, and for some and I've unmuted him.
Yeah, okay, can you hear me?
Yes.
Okay. Yeah, it's given the improvement after maybe a 5 days to a week from nudging for 1 week prior, can that be used as an initialization technique where you nudge for a week before a forecast and it improve the first 5 days that way? Have you thought of it in an application like that? Since she's muted. I can't hear the answer.
Oh, am I unmuted now?
Yes.
You would have to, you have this week, you don't know what the next week weather will be, right? So you always have, if you're looking at longer lead times, week 3 or 4, maybe you could do that, but for week 2, it wouldn't work because you have to wait until the end of week 1 to do that. But yeah, that's something that could be explored. It also tells you that if you improve your weather shorter range forecast in the tropics, that might actually have a positive impact in longer lead times in other regions, right?
The next question is from Ligia. Ligia, I think you have self-muted yourself, so I can't unmute you. Yeah.
Okay, can you hear me now?
Yes.
Okay. Okay, yeah, very interesting presentation. I was wondering if the results are sensitive to the strength of the nudging applied. Or in another way to ask this question is, how perfect do the tropics have to be in order for us to realize this improvement in mid-latitude forecast?
Yeah, so that's something we have thought about it a little bit, and you can weaken the strength of the nudging, but you're still nudging to reanalysis, right? So it's not, which includes the unpredictable component of the tropical signal. So what we've been thinking about is maybe doing some experiments where we nudge to a day 1 or day 2 tropical forecast, which would be closer to what the model can resolve, but we haven't done that yet.
But even nudging toward reanalysis, like, can you nudge just a little bit and see some result, or do you have to nudge a lot? Does it seem to be linear?
It seems to be reasonably linear, but we haven't done extensive testing of that. We have done some tests where we looked at different analysis. For example, we can nudge to something that is considered better, like air interim versus an older reanalysis, and we can see some difference, but it's nothing, but not large sensitivities so far, at least. And I think some of it is that we're really looking at large scale fields like U and winds at upper levels, and those are less different across reanalysis and will vary less when we do weaker nudging than if the connection was really sensitive to things that we know don't work well in the tropics, like thermodynamic profiles and whatnot, that are ultimately probably the source of this errors.
Thank you.
Okay, next question is from Cliff Mass. Cliff, you have to unmute yourself since you're self-muted. Cliff's question is, can you explain more why you see so many cases of a negative impact in the mid-latitudes when you are nudging the tropics towards reality? Could you only nudge divergence flow?
I'm unmuted now. Hi.
So that's a good question. This is something we have just started looking at, and those are I don't have an ensemble, so I don't know whether what would be the expected spread in a case where at week 4 you got such high anomaly pattern correlations, right? It could be that we are within reason of the model spread. That's would be my first concerning over interpreting this. And second, what observations it's doing to the tropics by week 4 is very different from what the model wants to do. So that could be playing a role as well. We have thought about relaxing just the divergent component of the winds in the tropics, and that's certainly something that is in our to-do list. I think that might produce some interesting results, at least in terms of comparisons. We have that set up where we nudge only the wings, but as far as I have looked, our relationships are very similar to when we relax all variables. We also have done some experiments, not extensive, not covering 20 years, where we relax only moisture and temperature. In that case, we see much less of an impact in the mid-latitude scale. So if we're looking at a plot like this one, at least based on a couple of seasons where we ran the moisture and temperature only, we were sitting a little above this red curve, that it's for that very narrow case of nudging, saying that just correcting thermodynamics in the tropics is not leading to enough of an improvement in the upper level circulation to see that full error reduction. So those are things that we're still thinking about.
But by the way, one thing consistent with your results, we ran 4 one-month convection allowing simulations. This was with MPAS, but it's similar to your configuration. And the cases where we improved convection in the tropics, that week 1, week 2, we saw week 3 and 4, we saw improvements in the skill over the mid-latitude. So that was consistent with your results.
Yeah, and that's reassuring, right? Because when you nudge throughout the 4 weeks, you have that constant forcing of essentially the answer at the southern edge of your area of interest.
Next question is from Lisa Benson. Lisa, I'm going to unmute you.
Yeah, can you hear me?
Yes.
Okay, great. Yeah, just following on some of the discussion here. So I'm a weather guy, and I'm just thinking the previous question, thinking about the one-day nudge. So if you only applied better initial conditions for one day, I think a previous question kind of asked that, it kind of get at maybe helping distinguish between, improvement and from the just the initial condition aspect versus the initial conditions mixed with, maybe some model aspects. So, but I think you've kind of, in the discussion here, has kind of answered that, well, it's a reanalysis, which isn't perfect initial condition, but right. So if this figure, if you only had one day of nudging in the tropics, I wonder what that would look like.
Yeah, and I mean, at least according to my statistical significance test here, you can see that the first day where you see a difference between the free forecast and the nudged one is at day 5. So it takes a few days to see an impact in the mid latitude. So I don't know if you nudge for just the first day you might not see something useful by day 5, right? There is this delay, and it might be that you would start seeing some benefit on week 2 if you nudge the first 3 days, because that would 3 plus 5 would give you some added skill, but still at day 7. And again, this day 5 days is a global average. If I looked at the anomaly pattern correlation over a particular region, those lags will change, right?
Right, thanks. Yeah, some good ideas there. Yep.
Yeah.
Lisa Benson, I think I unmuted you.
Yeah, hi Juliana.
Yeah, when I heard
yeah.
it wasn't Lisa.
Ironically, I had the same question, so it was covered. Well, more or less, if you only change the initial condition, is it lost right away?
I think that we have answered this question in your previous paper, right? Where we initialized the same model with ECMWF initial conditions, IFS conditions versus the GFS initial conditions. And by day, at least in the sample we were looking at, by day 4 was when you had the same skill, but for the first 4 days you performed better in the tropics.
Right.
And I would assume that
in
that
terms
would
of pattern
carry over.
Yeah.
That would carry over to some impact in remote regions as well.
Yeah.
I don't think we had enough samples in that study to look at that.
Yeah, I was thinking, like, for instance, now you showed like there was some 30% improvement in precipitation. What percentage would that be by simply replacing the initial condition in the tropics?
Yeah, I remember being pretty surprised by the fact that within the tropics, just by initializing with IFS, we saw differences in anomaly pattern correlations even by day 5.
Yeah, that's right. Yeah.
Hi, if there's no more question on the attendees, I have one question related to Cliff math. In that case run by Cliff with MPath is mostly related to MJO improvement in MJO. You improve the week 3, week 4 through teleconnection. Have you looked at the separate your results to see the cases, whether that's all due to MJO improvement or related to other cases?
So I have started looking at that. What I know from other studies is that you will see, if you're looking at a figure like this, mean absolute error as a function of lead day, in Young et al. 2010, they separate this between active and inactive MJO cases at initialization. So they look at some MJO index and they split their samples. And what they see is that you reduce errors in both cases, but you reduce more when you have an active MJO. And I think I can see that in my simulations as well. The answer is not as clear as what they have. So it might be that the index you use and whether you're looking at MJO amplitude at initialization versus at some lag might be playing some role here. The changes in the jet that I showed you in those composites suggest that there might be something with MJO phases as well. I think we still have to look at that in more detail, but I would expect some sort of MJO modulation.
Thank you.
With that, we're at the top of the hour. And if there are no more questions, we can call it a wrap.
All right. Thank you, everybody. Thank you, the speaker, Juliana. Great talk.
Thank you.
Thanks, everyone. Have a great 4th of July.